Welcome everyone. So in this lesson we're going to be talking about the unit circle. So I will say the unit circle is the big kahuna of all of pre-cal. This is one of the most important lessons that you're going to be talking about. So as kind of a warm-up, we're just going to talk about converting between degrees and radians that we talked about in the previous lesson. I will let you guys kind of peruse over what that as you need, and we're just going to kind of go right into it. So looking in, so the unit circle is used to describe the angle measurements and relationships between trig ratios of sine, cosine, and even tangent. So the unit circle contains the angle measures in both degrees and radians alongside their corresponding coordinates. So what we're going to do is we're just going to be given some sort of kind of sketch that contains a circle with some sort of horizontal component, some sort of vertical component, and then we're going to be using those two components to find the radius of that circle, which is going to represent your hypotenuse. And then, just like what we talked about between degrees and radians when we were plotting angles in standard position, what we're going to do is we're going to be finding the angle that is formed between the x-axis and that angle. And that's where some of these values are going to come from. So, starting off, we're given that sketch, and we're going to determine sine, cosine, and tangent of these ratios. So using theta as your angle that we're going to use, sine is going to be your opposite over your hypotenuse. So since we're using theta, I'm going to go ahead and label, so your opposite, your hypotenuse, and then your x value is going to represent your adjacent. So when I do sine, we're going to do y over r. So y over r. And if I want to do cosine, that's adjacent over the hypotenuse, which is going to be the x value over the r value. And then for tangent, that's going to be your y value over your x value, which is your opposite over your adjacent. And then if I want to do my reciprocal ratios, so like my cosecant, secant, and cotangent, that's going to be your reciprocal ratios of the previous. So if I want to find cosecant theta, that's going to be the reciprocal of sine theta. So that tells me that my ratio for cosecant is going to be r over y. And similarly for secant theta, we're going to reference cosine of theta, which is going to be r over x. And then for cotangent theta, we're going to reference tangent theta, which is going to be x over y. So what's going to happen is now we're going to actually do Pythagorean theorem using these values. So with Pythagorean theorem, that tells us that x squared plus y squared is going to equal r squared. So I'm actually going to just do that setup, and we're actually going to come back to it in a little bit. So now looking at the next section, we're going to look at a little bit more definite values. So the unit circle is always going to have a radius of 1. So knowing this information is actually going to be pretty crucial. So the unit circle, we're always going to assume it has a radius of 1 for right now. We're going to deal with expanding and condensing or changing that length later on. So starting off, knowing that we're going to have a radius value of 1, that means all my r values here are going to go to 1. So that means my sine of theta is going to equal y over 1, which is just my y value. Cosine of theta would be x over 1, which is just an x value. And then tangent of theta doesn't reference the radius at all, so we're just going to leave it as y over x. And then similarly for your reciprocal ratios, this is going to be, or cosecant theta is going to be 1 over y, secant of theta is going to be 1 over x, and then cotangent theta is going to be x over y. So tangent theta, cotangent theta, those are not referencing any sort of radius values, so those just stay how they are. So what's important to make the connection of is knowing that your sine theta is going to be equal to just your y value, and then cosine theta is equal to your x value, which is your horizontal component. So over here, if I'm ever using an x value, we're going to reference cosine of theta. And if I'm ever referencing a y value, we're going to use sine of theta. So knowing that, now we're going to come back up here to Pythagorean theorem. So if I know my x value is the same as cosine, and I know my y value is the same as sine, now I'm going to fill these in. So we're going to have cosine of theta squared plus sine of theta squared, and that's going to equal the radius of the unit circle, which is 1 squared. So this is going to be rewritten as cosine squared theta plus sine squared theta, and that's going to equal 1. Now, this equation right here, this is what we call a trig identity. Which this is going to be very important when we get to the next unit. But we're just going to kind of put a pin in that for right now. But just knowing this equation right here is going to be super, super, super important. So the order of addition doesn't necessarily matter. So you're probably also going to see it written as sine squared theta plus cosine squared theta is equal to 1. So this is the more common way of it being written, but it's also cosine first. Doesn't really matter. So knowing that, now we're going to move on. So we're going to discover the coordinates of the unit circle using your special rights that we talked about earlier. So the first angle value in your unit circle is going to be 30 degrees, or just pi over 6. Now what I did is I took the triangle that's formed by that 30-degree angle, and I am just going to move it over here. So I took this triangle, and we're just going to move it up, or blow it up over here. So I know the angle down here in the corner. I flipped it, which I don't know why I did that. So this is going to be 30 degrees down here. So if this is 30 degrees, what that means is this is going to be your 90-degree angle, and then that means we're going to have 60 degrees up here. So if I reference my triangle over here, remember in the unit circle, we're always going to have a radius of 1. So that means my hypotenuse value over here is also going to be 1. So what we're going to do next is now we're going to look at the ratios formed by these special rights. So the ratios of a 30, 60, 90, so across from 30 is going to be 1, across from 60 is going to be root 3, and then across from 90 is going to be 2. And then as I did before in a previous video, I'm going to do a method called DIMO. So DIMO is going to be divide in, multiply out. So if you need a recap of that, I would say go watch that video real quick and then come back. So I'm going to do DIMO. So I'm going to push in. I'm going to do 1 divided by the triangle ratio, which is 2. So when I divide in, that's going to give me 1/2. And then I'm going to multiply out. So I'm going to push outwards on the other side of the triangle. So 1/2 times 1 is going to give me 1/2. And then I'm going to push out going down, which is going to be 1/2 times root 3, which that's going to give me root 3 over 2. Now, what's important is knowing the horizontal and vertical components. Remember, the horizontal component is your x value, which is going to be in reference to cosine of theta. And then my y value, my vertical component, is going to be in reference to sine of that angle value. And in regards to the angle that we're using 30 degrees, which is also the same as pi over 6. So I will say, if I want to evaluate and determine what cosine of pi over 6 is, I want to know what's the horizontal component of that triangle, which is going to be root 3 over 2. So over here, cosine of pi over 6 is root 3 over 2. And then if I want to know sine of pi over 6, I want to know the vertical component, which is going to be 1/2. And then when we write the coordinate, as always, your coordinate is going to have some horizontal and vertical component. So your x and your y values are going to come from your cosine and sine values respectively. So my coordinate here is going to be rewritten, or not rewritten, but written as root 3 over 2, comma, 1/2. So the coordinate up here, where it has one of the vertices of my triangle, that coordinate on the unit circle is going to be root 3 over 2, comma, 1/2. And that's going to be in regards to an angle that is 30 degrees, which is the same as pi over 6. So now we're going to do the same idea for pi over 4 and then for pi over 3. So I'm going to try to do these a little bit quicker. So we're going to do the same idea. We're referencing the angle down here, which is pi over 4, which is the same as 45 degrees. So I'm going to reference it as 45 degrees, just so we can use our special rights. So we know this is going to be 90 degrees. And then, of course, this is 45 degrees up here as well. So your special right triangle ratios for 45, 45, 90 is going to be 1, 1, and root 2. And then the radius of your unit circle, as we know, is going to be 1. So now I'm going to do DIMO again, divide in. So when I divide in, I'm going to have 1 divided by root 2. So I have to rationalize, so that's going to be times root 2 over root 2, which is going to give me root 2 over 2. So I'm going to move this over here, actually. So now that I have root 2 over 2, that's going to be inside my triangle, and now I'm going to do multiply out. I'm going to push it out to get the other segments. So when I multiply out, so on the vertical component, we're going to have root 2 over 2. And then on the horizontal component, we're also going to get root 2 over 2. So the horizontal component, which is going to correspond to cosine, so cosine pi over 4 is going to be root 2 over 2. And then the vertical component of this angle is going to be root 2 over 2 as well. So then my coordinate would be root 2 over 2, comma, root 2 over 2. And then the same idea for pi over 3. So with pi over 3, that's the same as 60 degrees. So I'm going to use 60 degrees in this bottom corner so that I can use my special rights. So then my ratios across from 30 is going to be 1, across from 60 is root 3, then across from 90 it's going to be 2. And once again, we have a radius of 1. So I do dymo to push in. So 1 divided by 2 is going to give me 1/2. And then we're going to push out on both sides. So when I look at the lengths on my triangle here, we're going to have a vertical component of root 3 over 2 and a horizontal component of 1/2. So if I were to do cosine of pi over 3, that's the horizontal component, which is 1/2. And if I were to do sine of pi over 3, that's going to give me root 3 over 2, which means my coordinate is going to be 1/2, comma, root 3 over 2. So I'm going to actually go back to my triangles over here. I'm going to label these points. So when I did pi over 4, the coordinate we got here is root 2 over 2, comma, root 2 over 2. And then my coordinate over here when I did pi over 3 is going to be 1/2, comma, root 3 over 2. So now that we have those values, what's going to be important is now how we're going to translate that to the actual unit circle. So over here, the page before is kind of discovering the degrees and radians. I'm actually going to use the first page, and we're going to fill in the first quadrant, and then I'll come back up. So knowing our unit circle here has a radius of 1, we're just going to focus on quadrant 1 right here, which is what we just did. So if I look, let's try to do this a specific way. So the first thing I did was the 30 degrees. So that would be this triangle that I just did in blue. So if I have an angle value of 30 degrees, that is the same as pi over 6 radians, which gave us coordinates of root 3 over 2, comma, 1/2. And then if I do the next angle value, which was 45 degrees, that angle here, which I'm going to try to do this in standard position, is 45 degrees. So 45 degrees is the same as pi over 4, and that gave us coordinates of root 2 over 2, comma, root 2 over 2. And then last but not least, the other triangle that we got over here is still another 30, 60, 90 triangle, but instead of having a base angle of 30, now we're going to have a base angle of 60. I know this is kind of muddy. So the base angle of 60, which is going to be same as pi over 3 radians, which is going to give you 1/2, comma, root 3 over 2. Okay, and then the next part I want to look at is if we have an angle straight across, so on the positive x-axis, which means that would just give you an angle value of 0 degrees, which is 0 radians, which is going to give you a coordinate of 1, comma, 0, since we have a radius of 1. And then conversely, if I just go straight up on the positive y-axis up here, same idea, we have a radius of 1, so that coordinate's going to be 0, 1, and then that's going to be at 90 degrees, which is pi over 2 radians. So that's going to be the first quadrant, and now the big question I get is, how do I know what these other angles and radians are? Well, the angles and radians that we kind of did in the previous lesson in 5.2, I kind of cheated a little bit. I kind of gave you the values already, but I'm going to help you kind of discover what these values are. So rather than me just giving them to you, we'll go ahead and discover. So if you're not interested or don't need the discovery part, feel free to fast forward through this part. I'm sure that'll make this video much quicker. So to start off, I'm going to divide the unit circle into 4 equal pieces. Now keep in mind, when I go all the way around, that's going to be 2 pi radians. So if I divide it into 4 equal parts, so then that's going to give me 1, 2, 3, 4. So if I divide 2 pi radians amongst 4 equal parts, so whether you like talking about pizza, pie, whatever, cake, I don't know. So we're going to count by pi over 2 radians. So that means we're going to have 0, pi over 2. Whoops, let me actually do this another way. So this would be 0 pi over 2 radians, which is 0. And then 1 pi over 2 radians, which is just pi over 2. And then we're going to have 2 pi over 2 radians, which is just pi radians. And then 3 pi over 2 radians, which is 3 pi over 2 radians. And then if we go all the way around, then that's 4 pi over 2 radians, which is the same as 2 pi. So that's going to be where these 4 angle values come from. Now we're going to do the same idea, but now we're going to take 2 pi radians and we're going to divide it into 8 equal pieces. So I'm going to take my 2 pi radians, divide it over 8 equal pieces. So that means when I simplify, each little spoke is an account by pi over 4. So I'm going to take, let's use a little bit smaller highlighter. So I'm going to count by pi over 4. So we're going to have the same angle values from before. I'm going to bring down the 0, pi over 2, pi, 3 pi over 2, and 2 pi. But then I'm now going to bring in and introduce these values. So these values are going to be across the diagonals. So I'm going to try to draw these correctly. Okay, so what I'm going to do is in black, I'm going to do the values that we already know. So 0, 2 pi, and then we know this is pi over 2. I know this is pi. I know this is 3 pi over 2. And, of course, the 2 pi. So now, each spoke, I'm going to count by 1 pi over 4. So I'm still going to count the ones that we just did. So this would be 0 pi over 4, which is 0. Then 1 pi over 4, which is just pi over 4. 2 pi over 4, that is a 2, which is pi over 2. And then 3 pi over 4, which doesn't simplify. And then 4 pi over 4, which is just pi. And then 5 pi over 4, which doesn't simplify. 6 pi over 4, which simplifies to 3 pi over 2. And then 7 pi over 4, which does not simplify. And then 8 pi over 4, which is 2 pi. So now we have these measures of our unit circle. So now instead of dividing it into 8 equal parts, now I want to do 12 equal parts. So this is going to be on top of the values that we already have. So over here, we divided it into 8 parts. So 1, 2, 3, 4, 5, 6, 7, 8. Now I want to do 12 equal parts. So when I do 12 parts, I'm going to take 2 pi radians and divide it amongst 12 pieces evenly. So that means now we're going to count by pi over 6. So I'm still going to keep the values that we just got, but now I want to cut these pieces in half. Not really in half, actually. So this is actually going to go away, and then say cutting this one's going to be a little bit more challenging. So we have this piece and this piece. So each of these is going to have 2 of these blue lines. I'm going to try to do it symmetric, but it's probably not going to be symmetric. This one needs to go over a bit. Close enough. Okay, So now I'm going to divide this into the 12 equal parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I want to bring down all the values that I already found. So what's going to happen is we're going to have 0 and 2 pi. And then the pi over 4s are actually going to be in between. Oops, this is pi over 4. This is pi over 2. And then over here, halfway, this is going to be 3 pi over 4. We know this is pi. Then this part over here is going to be 5 pi over 4. Then we have 3 pi over 2. And then this halfway mark over here is going to be 7 pi over 4. And then, of course, all the way back around to 2 pi. So now each of these spokes we're going to count by pi over 6. So this is going to be 1 pi over 6. And then 2 pi over 6, which is pi over 3. And then 3 pi over 6, which is pi over 2. And then 4 pi over 6, which is 2 pi over 3. We have the 3 pi over 4 already, and then we're going to go to 5 pi over 6, which doesn't simplify. And then we have 6 pi over 6, which is just pi. And then the next divot, or the next spoke over here, which is 7 pi over 6. And then we're going to have 8 pi over 6, which is going to be 4 pi over 3. And then 9 pi over 6, which is 3 pi over 2. Then we have 10 pi over 6, which is 5 pi over 3. And then we have 11 pi over 6, which doesn't simplify. And then we have 12 pi over 6, which is 2 pi. So that's kind of discovering the unit circle. So now with that, now we're going to fill in the unit circle. So we already did the first quadrant with the positive x-axis, the positive y-axis, and then all these values over here. So what I'm going to do next is I want to fill in all the degrees. So all the degrees is going to be, then we have 120, and then 135, and then 150, and then to 180, and then to 210, and then to 225, then to 240, 270, 300, 315, 330, and all the way around to 360 degrees. So there's all your degrees. Now I'm going to fill in the radians. So the radians, so after pi over 2, then over here, just like we did in the drawing above, we have 2 pi over 3, 3 pi over 4, 5 pi over 6, pi radians, 7 pi over 6, and then we're going to have 5 pi over 4, 4 pi over 3, then 3 pi over 2, then 5 pi over 3, 7 pi over 4, 11 pi over 6, and then all the way back around to 2 pi for a full rotation. Now we're going to fill in the coordinates. Now the coordinates, what's going to happen is what I'm going to do is I'm going to just take my pre-existing coordinates that I already have, and I'm just going to reflect them over the y-axis and even reflect over the x-axis. So if I were to reflect these values over the y-axis, what's going to happen is the x value is going to become negative. So then my coordinate over here is going to become negative 1/2 comma root 3 over 2. Reflect over for 3 pi over 4, we're going to get negative root 2 over 2 comma root 2 over 2. And then at 5 pi over 6, we're going to get negative root 3 over 2 comma positive 1/2. So if I were to just reflect these three coordinates over here across the y-axis, that means your x value becomes negative and the y value stays the same. So same idea, if I go to pi, reflect it, and we're going to get negative 1 comma 0. And then the next part that I'm going to do is if I want to fill in quadrant 3 down here in terms of the coordinates, now I'm going to take my quadrant 2 values and reflect over the x-axis, which means my x value stays the same, but my y value is going to become negative. So my coordinate here for 7 pi over 6, we're looking at negative root 3 over 2. The x values are going to stay the same, but the y values are going to flip. So then we have negative root 2 over 2, comma negative root 2 over 2, and then negative 1/2, comma negative root 3 over 2. And then at 3 pi over 2 or 270 degrees, that's going to be 0, comma negative 1. And then for quadrant 4, you have options. You can either take your quadrant 1 values and reflect over the x-axis, or you can take your quadrant 3 values and reflect over the y-axis. Doesn't really matter which one you do. Personally, I like to work with quadrant 1, but that's just me. So 5 pi over 3, this is going to give you positive 1/2, and then negative root 3 over 2. Then 7 pi over 4 is going to give you positive root 2 over 2, comma negative root 2 over 2. And then for 11 pi over 6, you're going to have positive root 3 over 2, comma negative 1/2. And there you have it. There's your first unit circle. So you are going to be expected to memorize all these values. So I will say, we're going to be using the unit circle religiously for the rest of the year. So memorizing it is going to happen faster than you think. But what I will say is we're still missing part of the unit circle. Now what we're going to do is we're going to fill out the tangent values. So the tangent values, as a recap, so tangent of theta is equal to the y value over the x value, which means we're going to be filling out sine of that value over cosine of that value. So we're going to be writing out the ratio of sine over cosine in order to figure out the tangent value. So over here, we're going to start off at 0. Now I'm just going to do quadrant 1, and then we're going to reflect to get the rest. Okay, so tangent of 0 is going to be the same as doing sine of 0 over cosine of 0. Whoops, not theta. So sine of 0, which is the y value, is going to be 0 over 1, which is just 0. So tangent of 0 is just 0, which means it's coterminal with 2 pi. So that means tangent of 2 pi is also going to be 0. All right, now moving on to the next one. So at pi over 6, if I want tangent pi over 6, that is equal to doing sine of pi over 6 over cosine pi over 6. So that means we're going to have 1/2 over root 3 over 2. And I need to simplify this. So 1/2, I'm going to multiply by the reciprocal, 2 over root 3, which is going to be 1 over root 3. And then we need to rationalize. So multiply by root 3 over root 3, which is going to give me root 3 over 3. So tangent of pi over 6 is going to give me root 3 over 3. Okay, and then we're going to do the same idea. So tangent of pi over 4 is going to be sine of pi over 4 over cosine pi over 4. So we're going to have root 2 over 2 over root 2 over 2, which is just 1. So that's kind of a nice one. So tangent pi over 4 is just 1. Okay, and then the next one. So now we're going to do tangent of pi over 3. So once again, that is sine of pi over 3 divided by cosine pi over 3. So that means we're going to have root 3 over 2, all divided by 1/2. Then we're going to multiply by the reciprocal. So root 3 over 2 times 2 over 1, which is just going to give us root 3. So tangent of pi over 3 is just root 3. So I'm circling those so you can kind of see like what the value is and all this kind of mess. But I'm not going to solve each and every single one of these values. So now we're going to go up to pi over 2. So tangent of pi over 2 is going to be sine of pi over 2 over cosine pi over 2. So this is going to be 1 over 0. Now remember, this is the naughty number that so many people get wrong. You cannot divide by 0. So what this means is tangent of pi over 2 is undefined. I can't spell. There we go. All right. So be very careful that you're not getting tangent of pi over 2 mixed up with tangent of 0, because tangent of 0 is 0. Tangent of pi over 2 is undefined. Those are not the same thing. 0 is not the same thing as undefined. 0 is a value that is measured as the symbol of nothing. Undefined means that number cannot exist. You break math. Be careful. That's all I can really say. All right, so now I'm going to do the same premise. I'm going to take all my tangent values and reflect to get the rest of the values. So if I want to find tangent at 2 pi over 3, we're going to reflect over. So tangent 2 pi over 3 is going to be negative root 3. Tangent 3 pi over 4 is going to be equal to negative 1. And then tangent 5 pi over 6 is going to be equal to negative root 3 over 3. Then tangent of pi, I cannot write, is going to be equal to 0, not undefined. Okay, and then down here, now tangent of 7 pi over 6. Now keep in mind, now we have a negative over a negative, so it's going to be a positive. So this is going to be positive root 3 over 3 when I simplify. So then tangent of 5 pi over 4, this is going to be positive 1. Tangent of 4 pi over 3, that's a 4. Oops, move over. This is going to be positive root 3. And then tangent 3 pi over 2, this is undefined. So I'm totally fine if you write just U and D for undefined, totally fine with that. Okay, and then moving on, quadrant 4, so tangent of 5 pi over 3. Now we have a negative value over a positive value, so that's going to be a negative value. So this is going to be negative root 3. And then tangent of 7 pi over 4 is going to be negative 1. And then tangent of 11 pi over 6, that's going to be negative root 3 over 3. So your unit circle with your tangent values. Now, of course, then you can even build up and even do your reciprocal ratios. Like I could even find cosecant, secant, and cotangent of all these values too. But let's just focus on the unit circle for right now. This is what you need to spend a lot of your time learning, doing, memorizing, and understanding. So with that, now we're going to go into what values are positive and negative. So there's a mnemonic up here. It follows the same idea as your, It follows the same mnemonic as like understanding the order of your quadrants. It goes in a giant C. So we follow the mnemonic, all students take calculus. So it's really up to you on if you want to use this mnemonic. It helps you understand which values are positive and negative in the quadrants. So in the first quadrant, we have a positive. So cosine of theta is positive and sine of theta is also positive, which means if I do tangent of y over x, that means tangent's also positive. So everything is positive, nothing is negative in quadrant 1. And then in quadrant 2, so we're going to have a negative positive. So my x value is negative, which means cosine is negative. But in quadrant 2, my y value is positive, which means sine is positive. And if I do my tangent, my y over my x, I have a positive over a negative. So tangent is also negative. And then in quadrant 3, same idea. So we have a negative comma a negative. So sine and cosine are both negative. So sine theta and cosine theta. And then if I do a negative over a negative for tangent, we actually get a positive. So tangent's actually positive in quadrant 3. And then for quadrant 4 down here, so we're following the pattern of a positive negative. So your x value is positive, which means cosine's positive, and then your y value is negative, which means sine is negative. So when I do my y value over my x value, I get a negative over a positive, which means tangent is also negative. So the mnemonic that you can use is all students take calculus, and you can understand and know which values are positive, and the rest would be negative. All right, now looking at the next page, now that we kind of wrote out what the unit circle is and what it does, now we're going to actually use the unit circle to evaluate specific values. So this is where you really need to know your unit circle like the back of your hand. So what I even tell students is literally just Google a completed unit circle on the internet and literally just make it your wallpaper. That way you're forced to look at it every time you open your iPad or even your phone. I'm not going to require that you do it, of course, but I will say the students that make the unit circle their wallpaper, at least for the duration of the unit, they memorize it much faster. Just saying. Okay. Now what we're going to do is we want to find the exact value using the unit circle. So if I want to find cosine of pi over 6, I want to know what is the x value at the angle pi over 6. So of the coordinate, I'm going to go to pi over 6. And then looking at the coordinate, if I want cosine, that means I want the x value, which means that answer is going to be root 3 over 2. Okay, and then over here, I want sine of pi over 4. So because I'm doing sine, I want the y value. So if I go to sine of pi over 4, or if I go to pi over 4 rather, look at the coordinate, I want sine, which means I want the y value, which means I want root 2 over 2. Next, now we have tangent pi over 3. So this is where it's just going to be about recall. So sine pi over 2 is going to be 1. Cosine of 0 is going to be 1. Cosine pi is going to be negative 1. Sine of 0 is going to be 0. Sine of pi is also going to be 0. So cosine of negative pi over 4, this is where I decide to throw in some coterminals at you. So you could do cosine negative pi over 4 plus 2 pi if you don't want to deal with the angles, or the negative angles. So this is the same as cosine of 7 pi over 4, which cosine is your x value. It's still positive in quadrant 4, which is root 2 over 2. So you don't have to do the coterminal if you don't want to, but we're going to be throwing things like that at you. All right, and then over here, sine of 4 pi over 3. So that's in quadrant 3, which is going to be negative, which I believe is negative root 3 over 2. So kind of how fast I'm going, like that's how fast we want you guys to go. So it's just going to be a matter of patience, practice, rinse and repeat. Just keep going. Okay, so cosine of 5 pi over 3. So that's going to be your x value, which is going to be 1/2. And then tangent 7 pi over 4, that's quadrant 4. Tangent's negative in quadrant 4, and that's going to be negative 1. And then this is where I start throwing some of the coterminals at you. So sine of 8 pi over 3, I'm going to subtract 2 pi. So I'm going to do 8 pi over 3 minus 2 pi. But I'm going to rewrite 2 pi as 6 pi over 3, which means this is the same as doing sine of 2 pi over 3, which in that case is root 3 over 2. Okay, and then tangent 7 pi over 6, so same idea, you can do a coterminal. That's the same as tangent of 5 pi over 6, which in this case is going to be negative root 3 over 3. And then cosine of 11 pi over 4, it's doing another coterminal. You can subtract 2 pi, so 11 pi over 4 minus 8 pi over 4 is going to give you 3 pi over 4. So that would be cosine of 3 pi over 4, which is going to be negative root 2 over 2. Then tangent negative 3 pi over 2, add 2 pi, that's going to put you at pi over 2. Tangent of pi over 2 is undefined because you can't divide by 0. Okay? All right, so that's when we give you the angle value. Now we're going to go a little bit backwards. Now we're just going to find the angle value when it's in one revolution, and note that there could be more than one value. So I want to find all the values where my y value is positive root 3 over 2. So if I look back at y equal to 3 pi over 2, So I have a positive 3 pi over 2 for my y value here, and also if I go across, it's at 2 pi over 3 and pi over 3. So that's what I mean by we can have multiple values. So this is going to happen at angles of pi over 3 and 2 pi over 3. So if I draw a little circle, what I mean by this is we're looking to see where the y value is equal to root 3 over 2. And that happens at two places, which is pi over 3 and 2 pi over 3. Now, same idea for cosine theta. So let me draw my picture first for this one. So cosine of positive root 3 over 2, so that's going to happen in in quadrants 1 and 4. So I want to know what these two angle values are going to be. So when my x value is root 3 over 2, so that's going to be here and here. So we're looking at pi over 6 and 11 pi over 6. So that means theta is equal to pi over 6 and 11 pi over 6. So when I look at sine, we're looking left to right to see what are the two values. If I'm looking for cosine, I'm looking up and down to see what are those two values. And then for tangent, this is where you're actually going to be looking diagonally. So tangent, where it's positive root 3, so it's going to be positive in quadrant 1 and 3. So I'm looking to see what are these two values on the unit circle where tangent is positive root 3. So if I look here, that's going to happen at pi over 3. And also if I go down across the spoke, that's also going to happen at 4 pi over 3. So the tangent values are going to be diagonal from each other. So you're going to look across the spoke. So this is going to happen at pi over 3 and 4 pi over 3. Now, one thing to notice, which I'm going to get into later, notice how these values are pi radians apart. And that's for tangent. So we're going to get into that later. Okay, so I'm going to kind of speed run these. So cosine, where it's equal to 0. So where is the x value equal to 0? Well, that's going to happen when you go straight up and down. So that's at pi over 2 and 3 pi over 2. Where is sine 0? So where is the vertical component 0? So that's going to happen at 0 radians and pi radians. Where cosine is equal to only positive 1. So that's only going to happen at 0. If I do cosine of pi, that's negative 1. So we just have one value in that case. Now, same idea here, where sine is equal to 1. That's only going to happen at pi over 2. Because if I do sine of 3 pi over 2, that's negative 1. So these types of values are only going to have 1. So tangent equal to 1, so that's going to happen in quadrants 1 and 3. So that's going to happen at pi over 4 and 5 pi over 4. Now, once again, notice for the tangent values how these are, I cannot draw an arrow. Notice how these are pi units apart. Okay, now when tangent theta is equal to negative 1, so that's going to happen in quadrant 2 and quadrant 4. So that's going to be at 3 pi over 4, but also 7 pi over 4. And then for cosine theta equals root 2 over 2. So cosine is positive in 1 and 4, which means that's going to happen at angle values of pi over 4 and 7 pi over 4. Okay, and then sine of theta equals negative root 2 over 2. Sine is your y value. It's negative in quadrants 3 and 4. So that means that's going to happen at 5 pi over 4 and 7 pi over 4. And then cosine theta equals negative 1/2. So cosine is negative in quadrant 2 and 3. So that's going to be at angle values of 2 pi over 3 and 4 pi over 3. All right, so that's looking in terms of just one single revolution. So when I'm between 0 and 2 pi. Now the next part is when I want to find all possible values. So this is if we have no limitations. So what's going to be a little tricky about this is we have a very specific notation that we have to write. So we want to include every possible value. So instead of having to go through and write every single possible value, you technically can't write them all because these equations are going to oscillate back and forth, so you can't write everything. So what we're going to do is we're going to introduce a notation where we include all the elements of an integer. So what we're going to do is we're first just going to evaluate it just as normal. So sine of theta equal to root 3 over 2. Well, sine is positive in quadrants 1 and 2, so that's going to be at pi over 3 and 2 pi over 3. Sorry, my brain stopped working for a second. Now, if I want to include all possible values, what I need to do is I want to include all the coterminal angles, which means I want to add those revolutions. Now, remember, with coterminal, that means we're going to add 2 pi. And if I want all possible values, we're going to add in a value called k to represent an integer. So what I'm going to do is I'm going to say k is an element of the number group of the integers. So this is a very fancy, complicated way of saying k is an element of the integers. So k is an element of, which is the epsilon. This is the Greek letter epsilon. And then it's going to be the integers, which is a number group. So that's what this is saying. So over here, instead of writing it as the singular values of pi over 3 and 2 pi over 3, I'm actually not going to write it as the singular values. So you have to write it as pi over 3 plus 2 pi k to account for all the coterminals. And then we're also going to write in 2 pi over 3 plus 2 pi k. Now, if I just write this, you're still missing a component of your answer, and that's because you need to define what the letter k is. So your k, you have to write k is an element of the integers. Now, my students in the past, they like to call this kes. I don't really care what you call it as long as you write it. So this would be your full answer. If you don't write k is an element of the integers, I would technically take points off because your answer is incomplete. Okay, now for cosine theta, now we have all the values where cosine is equal to positive root 3 over 2. Now, this is going to happen at pi over 6 and 11 pi over 6. Hello? So I want to account for all the coterminals, so that means I need to write it as pi over 6 plus 2 pi k, but then I also want to rewrite it with 11 pi over 6 and all of its coterminals, so 2 pi k. And then you also need to include where k is an element of the integers. Ta-da! All right, tangent. So tangent theta is equal to root 3. So this is going to happen at pi over 3 and 2 pi over 3. So if I were to just write out theta equals pi over 3 plus 2 pi k, and then theta is equal to 2 pi over 3 plus 2 pi k, so we have a little bit of an issue. So k represents an integer, right? So when I say an integer, that means k could equal like -1, 0, 1, 2, 3, so on and so on and so on. But what happens if I use this top equation and I plug in a k value of 1? So I'm just going to kind of sidebar for a second. So over here, if I do pi over 3 plus, hold on, what was I doing? Yeah, plus, nope, hold on, what am I trying to do? Those are not, because that's not my answer, ha ha ha. That's why I was like, why does this look weird? Okay, sorry y'all. So this is pi over 3 and 4 pi over 3. Oh Lord, I need to get more coffee or take a nap. So this would be 4 pi over 3 plus 2 pi k. So sorry about that, y'all. Whoops. So now if I plug in a k value of 1, there we go. So then if I do pi over 3 plus 2 pi times 1, pi over 3 plus 2 pi, hold on. Yes, because we're looking at pi over 3. Sorry, y'all. Pi over 3 for pi over 3. So what's happening is these values right here, I'm going about this wrong. I'm so sorry. So what's happening is notice how these values are across the spoke from each other. So if these values are across the spoke from each other, notice how that's just a difference of just 1 pi. So I don't need to go around a full rotation. I can just go around a half rotation to get those values. So instead of adding 2 pi for a full rotation, what I can do is I can just add pi a half rotation. So what I'm trying to get at down here with these values is because these values are across from each other on the unit circle, I can actually just write this as a single equation, meaning I could just write this as pi over 3 plus 1 pi k, where k is an element of the integers. So then if I do, this is where I meant to do a k value of 1. So if I do a k value of 1, that means we would have pi over 3 plus pi, 1 pi, which is pi over 3 plus 4 pi over 3. Jesus, I cannot do math. 3 pi over 3, which gives you 4 pi over 3. So what I'm trying to get at here is instead of writing two separate equations and representing all of their coterminal angles, I can condense this to one equation with a half rotation and still account for all the coterminal angles. So it's a way of condensing the information into fewer values. So long story short, if you can condense it from two equations plus 2 pi k to one equation plus pi k, we want the pi k. We want the condensed version. So the big way that you want to ask yourself this is ask yourself, are the values across from each other on the unit circle? If they're across from each other on the unit circle across the spoke, use one equation, not two. All right, so now over here, cosine theta equals 0. So this is going to happen at pi over 2 and 3 pi over 2. So ask yourself, pi over 2, 3 pi over 2, are these across from each other on the unit circle? If they are, we want one equation with pi k. If they're not, we want two equations with 2 pi k. So pi over 2 and 3 pi over 2 are across from each other, so we want a single equation using the smaller radian value plus pi k, where k is an element of the integers. Okay, I'm going to do a few more. So sine of theta equals 0, so where sine is equal to 0. So this is going to happen at 0 and pi. So ask yourself, 0 and pi, are those across from each other? If yes, one equation with pi k. If not, two equations, 2 pi k. So 0 and pi are across from each other, so we want just one equation with pi k. And then I can rewrite 0 plus pi k as just theta equals pi k, where k is an element of the integers. So this is the equation we would want. Okay, and then cosine theta equals 1. So this will only happen at 0. It's not going to happen at pi. So what that tells me is I only have one equation, so it's going to be plus 2 pi k, because there's no other value that's going to have it. So I want 0 plus 2 pi k, where k is an element of the integers. So I can just rewrite this as theta equals 2 pi k, where k is an element of the integers. So this is the equation I want. Okay, and then same idea where sine of theta is equal to 1. This is only going to happen at pi over 2. There's no other value, so I want all the coterminals, which means I'm going to add 2 pi k. So theta is equal to pi over 2 plus 2 pi k, where k is an element of the integers. Okay, and then tangent theta equal to 1. That's going to happen at pi over 4, but also 5 pi over 4. So pi over 4, 5 pi over 4, those values are across from each other, which means I want one equation plus pi k. So that means theta is equal to pi over 4 plus pi k, where k is an element of the integers. Okay, and then tangent theta equal to -1. So that's going to happen at 3 pi over 4, but also at 7 pi over 4. So ask yourself, are these across from each other? Yes. So one equation or two equations? One equation. Plus pi k or plus 2 pi k? Pi k. So that means we want theta is equal to 3 pi over 4 plus pi k, where k is an element of the integers. All right, and then cosine theta equals root 2 over 2. So this is going to happen at pi over 4, but also 7 pi over 4. So ask yourself, are these across from each other? No. So that means we want two equations with 2 pi k. So that means we're going to have theta is equal to pi over 4 plus 2 pi k for all of its coterminals, and then 7 pi over 4 plus 2 pi k. And k is an element of the integers. So you only have to write the k is an element of the integers once per equation set. Okay, and then we'll go ahead and knock out these last ones. So sine of theta equals negative root 2 over 2. So that's going to happen in quadrant 3 and 4. So that's going to be at 5 pi over 4 and 7 pi over 4. So ask yourself, are those across from each other? No. So one equation or two equations? Two equations. Add pi k or add 2 pi k? We want 2 pi k. Okay, so in this case, we're going to have 5 pi over 4 plus 2 pi k. And then we also are going to want 7 pi over 4 plus 2 pi k. And then where k is an element of the integers. And last but not least, cosine theta equals -1/2. So cosine is going to be negative in quadrants 2 and 3. So that's going to happen at 2 pi over 3 and 4 pi over 3. So ask yourself, are these across from each other? No. So one equation with pi k or two equations with 2 pi k. I want two equations with 2 pi k. So this is going to be theta equals 2 pi over 3 plus 2 pi k. And then I also want 4 pi over 3 plus 2 pi k. And then we're going to include where k is an element of the integers. Okay, and then down here, this is going to be where we adjust the length of the radius of the unit circle, but I'm going to skip over this. I really just want you guys to focus on this part up here. I'll probably still talk about this later on, but for right now, in terms of the video, I'm sure this is long enough. So have fun.